The dreaded debug window has gotten the best of all of us. It's a horrible feeling spending all that time writing your code just to get hit with a debug window not even 5% into what you've just written. You would think, as annoying as this is, it would at least be a good way to find and debug errors, but you would be wrong. There are several problems with the VBA debug window, and here are a few. First of all, it makes you feel defeated. And even worse, if you built a tool for somebody else and it pops up while they're using that tool, you look like a complete amateur. No code beyond the error will be tested, meaning that there could be more errors that you don't even know about. And it only checks for VBA specific errors. There's no option for customization. So I've built what I think is the best VBA error handler, and here are a couple of the key features. It's plug and play. Just download this workbook, start writing your code in the designated spots, and the error handler will do its thing. It stops the debug window from ever popping up. After an error occurs, you have the option to allow your program to continue to run. Therefore, all the code that you've written can be tested. It creates a text file, which will log the run results for each of your subroutines. It times all of the subroutines, which will allow you to spot potential bottlenecks in your program. You can create custom errors within your code, and they will be treated just like VBA errors. If a user runs into an error, the text file that is created will provide the user with instructions on what to do to solve the problem, making it look like you've accounted for these potential problems and making an overall better experience for the user. There's a built-in developer mode that can be enabled when testing your code. And of course, all of this is completely free. You can download this workbook right now and start using the error handler in all of your projects. Just go to my website, which is linked in the description, and click here. Make sure you follow the instructions further down the page so that you'll be able to use the code within the workbook. Now let's jump right into how the error handler works. All right, now that you guys have downloaded the file and are able to follow along, let's jump right into step number 2. How does the error handler work? So we're going to do a brief overview on how it works. And then in steps 3, 4, 5, and 6, I'm going to walk through the 4 crucial subroutines that make up this error handler. And then in step 7, I will show you how to create custom errors, like I mentioned in the intro. And in step 8, we'll talk about dependent errors. And in step 9, I'll show you how to use this error handler using nested subroutines. And there's actually 2 ways you can do this. I'll show you both. So let's jump right into step number 2. How does it work? So you can see here, this is what I like to refer to as my master subroutine. This is the subroutine that will be executed when the button is clicked by the user on the front end. Now, right away, you can see we only have one global variable, and we have a Boolean value for developer mode. Now, I will get to this, but for now, we are just going to leave it as false and ignore it. And then you can see we have 2 subroutines being called here at the top, and they both say default. That means these are what I'm talking about when I am talking about the error handler that I built. This one here, I did not write. I got this from Excel Macro Mastery, and I use this for every project. Turn stuff off and turn stuff on. Those I did not write, but I do include them in this workbook, and I use them for every project. So taking a full look at our master subroutine, you can see we have 2 defaults at the top and 3 defaults at the bottom. And then in between this line and this line is where all of your code will go. And here I have 6 subroutines that are all going to cover different sections of this video. And for now, we are going to go into test 1 subroutine, and I'm going to show you how the error handler works with no errors happening. For this example, we are going to start with the developer mode in true. So let's go ahead and walk through. And for these first 2 subroutines, we are just going to step over them. And we are going to jump right into call test 1. So step into this one, and you can see we are brought to a subroutine. And this is sub 1. The first line we execute in this subroutine is on error, go to error handler. If you downloaded my workbook, you should leave this the way it is, but if you are writing this from scratch, then you can name this whatever you want. The important thing is that at the bottom here, whatever you wrote in that top line, it needs to say the same exact thing here, and then have a colon, and then have your LogErrors subroutine. All right, so after we execute this line, what this is saying is when VBA encounters an error, instead of giving the VBA debug window, we want it to go to the error handler, and it will jump down to these lines of code. The second line of code here is a string variable subname, and we are just putting the value of whatever the name of the subroutine that we're currently running is. And the reason I do this is so that we can see where errors happen or which subroutines are running successfully. The next two lines here are both default subroutines that you should not touch or alter, and we are going to step over those. You should see test1 has begun in your immediate window. Now this is taking the subname string variable and putting it together with has begun. And we are going to start a timer, so that will time all the code that you write here. And it will show you how efficient your code is. So we'll step over that. A timer now has begun. And we are going to execute some very basic code. All right, you can see H4 is right here. And when we execute this line, nothing will happen. But let's actually put something here. I was supposed to say test, but this should clear it out when we execute this line. And it does. And then this line should put pass, and it does. So there were no errors in this block of code where your code should go. Now we will stop our timer now that our code has completed. And we stepped into it, no big deal. And we will call the developer messages end, which will give us our message. It says test1 ran successfully and took 61.8 seconds to run. Now this would appear down here, but I messed it up by putting my cursor here. So we will do that again. And then you see exit sub is being called. And these two lines of code are never touched. So even though we are calling go to the error handler, this never happens until an error is hit. So then we exit the sub and we go to our default code statements at the bottom. We will step over this, and step over this. And you see we get a message that says no errors. And then we have successfully run our master subroutine. All right, so now we know that test1 has no errors in it, and you saw the basic layout of the subroutine. That layout will be the same for every subroutine you write if you use this error handler. So let's go ahead and uncomment test2, and we'll walk through both of these. So let's step into our code, step over the first two, and step into, or just step over test1. And you can see here test1 has begun, and it ran in this many seconds. Now we will step into test2, which will have an error. You can see this is the same exact layout as the test1. The only thing that is different is the subname variable has been updated to this subname. We have the onError go to error handler, subname equals test2. We will start our message, and we will start our timer. You can see down here, test2 has begun. We will attempt to run these two lines of code, which will fail. This one should work. If we put any value in H5, this should clear it out. But when we try to write pass to H5, just like we did in H4, we are attempting to do that in worksheet number 2. And if you look at the bottom left, worksheet number 2 doesn't exist. And this will cause a subscript out of range error. Let's see what happens. We execute that line of code, and it immediately brings us to call LogErrors. And you see any code below when the error happened in this one subroutine will not be executed. So stopping our timer will not happen, and calling our end message which tells us it ran successfully and took this much time to run, will also not happen. So let's step over log errors and see what happens. You can see if we bring up our immediate window, test 2 has begun, and it will tell us the error number, 9, and the error reason, subscript out of range. But what we don't see is the debug window, which is a good thing. And now, usually, VBA would not give you an option to continue. But if we continue, you can see we come back to our master sub. Now, if these were not commented out, these would continue to run, and we would continue to test those subroutines. But we will step over these last few lines, and you can see we have errors exist. So that is basically how the error handler works. You have one line that says, on error, go to error handler, here. Now that tells VBA how to react. When an error is encountered in your code, somewhere in here, this will be triggered, and this subroutine will be called. But if no errors are encountered, then your code will run as normal. Your timer will stop. You will get a message telling you that your code ran successfully, and the sub will exit like normal. So now that you guys see how the error handler works on a basic level, what happens when no errors exist and what happens when an error does exist, we can get into what these subroutines are actually doing. And we're going to start with error handling _ start, which happens in our master subroutine. So if we go to button, you can see this is one of the default subroutines at the top. This whole error handler behaves differently depending on the value set for developer mode. If developer mode is set to true, we are telling the error handler that we are currently working in VBA and we want the error handler to work in one specific way. If it is set to false, we are telling VBA that we have given this tool to a user or a client and we want the error handler to work in a slightly different way. Now, obviously, when it's set to true, it will be easier to debug and work strictly in VBA. When it is set to false, it will be more convenient for you and the user if an error does happen. So in order to see what error handling start is really doing, this needs to be set to false. So we are saying that right now, this is in a state where a user or client is using this. We have delivered it and they will be using it. So let's set it to false and then step into this subroutine. So we will step over turn stuff off and step into error handling start. All right, so you can see the first thing we do in this subroutine is we have an errors long variable and we set it to 0. And this is a global variable and we need to set it to 0 at the start of every run. So that is the first thing that we do. And this happens regardless if we are in developer mode or not. You can see the second line is where we test, is this in developer mode? Yes or no. If developer mode equals true, yes we are in it, then exit the sub and do nothing. This subroutine will not do anything if we are in developer mode. Instead of exiting the sub, like this command here says, we enter the code because we set this to false. So the first line, after we've actually entered this subroutine, we see that we have a save path variable equal an input box. So make sure to have a little breakpoint here by clicking in the margin so that this does not automatically execute, and execute this yellow line. You can see we have a file path, and provide that a file path where you would like to save your documents from this project. Once we give the file path, that now exists as a string in the save path variable. And on this line, we are creating another variable that says save path exists. And we're going to use the dir function on the string that we just took in with a backslash, and then using the VB directory function, which is going to check if this is a real accessible file path on this computer. So when we execute this, save path exist should equal nothing if the save path is invalid, meaning they didn't put in a valid file path, or it should have a period in the string that says something does exist. So that is what this if statement is doing. It's just verifying that the save path does not equal nothing, as in the user just clicked OK and didn't put anything in the save path input box. And then it's checking if save path exists is empty, in which case the file path they did provide does not exist, or VBA just does not have access for some reason. If either of those are true, then a message box will be prompted to the user telling them that this does not exist on this computer. Please double check your input and try again. And we will call turn stuff on, and we will end, which will terminate the entire program. But since we gave it a valid save path, we will just hit end if. Now it's very important that we do this validation because we will be automatically saving files. And if the file path that they gave us is invalid, we will later get a debug error because of that. So it's better to check and validate that it does exist now so that we can not worry about those errors in the future. Moving on, we are going to do a quick do while loop, which will stop us from overwriting our files that we're creating. So the whole purpose of this subroutine is to create a blank text file that is going to log our progress as we run through our code. So what we're doing here is we are just creating a variable called file name, which will just store the name of file if any files in the save path provided equals anything underscore errorlog.txt, which is the file that we create. So this is saying we may have run this tool before and we may have created an error log already. If that is the case, we want to find it. That way we do not overwrite it. So we have a counter and we have a do while loop. Right now, this is a blank value, which means it will not enter this, meaning that no files exist within the save path with this name. So the counter will remain at 1, and we will name the new file that we're creating 1 underscore errorlog.txt. If a file was found, as in 1 underscore errorlog.txt did exist in this file already, we would have incremented to 2. So then we would have created a file called 2 underscore errorlog.txt, not overwriting our previous work. And this will continue to go up until no more files have been found, ensuring that we never overwrite previous files. So this variable will be given the value of our save path and our save name. The next two lines here are setting two objects. Now this line is not really doing anything except preparing the computer to create something. So nothing has been created. Now before I execute this line, let's pull up our file folder. Now this is the location that I gave the program initially. So when I execute this next line, we will see our text file populate here. You see, the only thing here now is the tool that we're currently using. So if we minimize this, execute this line, and pull up our file folder again, nothing is here. Since we're on OneDrive, we do have to refresh the file. When we refresh, you can see a text file named 1 underscore errorlog.txt has been created. We will open that and you can see it's just a blank text file. And the last two lines of this code are this error log was created on, and it gives the value now, which is today's date and current time. And then it will log a blank line just to create some separation. So we will run those two and we will check our text file again. And you can see this error log was created on 4/9/2024 at 1907. So it is telling us when this was created. After the file has been created and the time and date have been logged, we will exit the sub and we will start executing our actual code. So a quick overview of this subroutine, all this does is it takes in a string value for a file path, it validates that file path, it checks so that we don't overwrite previous files. It creates a new text file, and it logs the date and time that was created. And that's it. It doesn't do anything beyond that. It just prepares us to start logging our progress through our code. And then whatever code you're writing will begin to run. So let's clear our immediate window and let's begin. Let's step into test 1. Now we've already reviewed test 1, so we will go a little bit quick. We can step over on error, go to error handler. We give subname test 1. We call dev message start, which tells us which subroutine has started to run, and we start the timer. Now, it's being logged here in the immediate window for our convenience, but since we set our developer mode to false, which means it is in user mode, it is also logging the progress in our text file. So test 1 has begun. You can see that here. Now if we continue, we execute all of our code successfully. There were no errors. And we can stop our timer, step through this, and we can call developer message end. And that will tell us test 1 ran successfully and it took 30 seconds to run. Now again, this is being logged in our text file as well. So if an error did occur, we can see test 1 began and it finished and it took this long. So we know this is not the problem. We will then exit sub without hitting the error handler, and we will move on to test 2. Let's step into that. Move our immediate window down a little bit. And the same thing will happen. We will get a message, test 2 has begun, and we will start a timer. Now we know this is going to error, so let's make it happen. We try to execute this line, and we hit an error, and it says call error log. And we execute that. You can see in the immediate window again, error number and error reason, subscript out of range. Now let's open up the error log.txt. You can see test 2 has begun, error number 9, error reason, subscript out of range, and we have one more additional line that says, please contact your VBA developer. Now this happens because it is giving the user as much information as we can. When it comes to a VBA specific error, such as subscript out of range, this is not typically an error that can be resolved on the user's side. Now what I mean by that is this is an error that needs to be fixed in the code. There are errors that the user can fix, such as not providing the correct save path. That is why we give them a message and tell them explicitly, this is what you need to do so this error does not occur again. But when it comes to VBA specific errors, more than likely, you're going to need a developer, someone familiar with the code, to come in and fix it. But giving the user this text file, which tells them something, please contact your VBA developer, it is much better for them to open an error log and then see some instructions rather than just having the debug error window pop up, hitting the end or the debug button, and then being brought into VBA. They have no clue what the code is, what it's trying to do, and you could risk them screwing up the code. So this is much safer and a better user experience. Now, like I said, we hit an error here and we executed the error handler down here. This code in between will not be executed. We will return to our master sub and we will error handler end here, which we will step over, we'll turn stuff off, and we will close our message. You can see here we have a fairly long message for the user, and this says errors were encountered during this run. Please double check your inputs and try again. If errors continue to occur, review this file for further instructions. And that's when we provide them the file path and file name to the error log that was created so that they can see the instructions that we're telling them. In this case, it was please contact your VBA developers. In other custom cases, it can be something else, such as you did not enter the correct field You left this field empty. It could be anything you want it to be, which we will get to. So let's open up our text file one last time and see if anything else happened. You can see here, we ran test 1 and it finished successfully, and we ran test 2 and it errored, and it gave us instructions on what to do. And at the end, it totaled our errors for us. Total errors equals 1. Now this takes place in the error handling end subroutine, which we will look at in just a moment. All right, so now that we've just completed step number 3, we know that the error handling start subroutine, all it does is it creates a blank text file. And now we're going to move to LogErrors. When we have the blank text file and we encounter an error, like in test 2 subroutine, what is LogErrors actually doing under the hood? That's what we're going to jump into now. All right, back to our master sub. We will step into this subroutine. We will call turn stuff off, call error handling start, be prompted for our save path. We will provide them the save path, and we still have our break in our code, so we will take that off and execute this. Now you see, this time we did enter this do while loop, and that's because I left the one_errorlog.txt file that we just created. So now you will see when we hit this line here, when we create our new text file, we should have two_errorlog.txt, not overwriting our previous error log. So let's go ahead and execute all of this. Right before we step into test 1, let's open up our file and refresh. And we can see two_errorlog.txt has been created, and it just says it was created now at 4/9/2024 at 19:15. One_errorlog.txt was the error log we just created in our previous example. So we know test 1 is going to have no errors, so we are going to step over that. And we know this one is going to have errors, so let's step into it so that we can step into the LogErrors subroutine that will be called. So let's step over these first few subs. Let's step over this, and let's step over this. Okay, so we are about to step into call LogErrors because this line contains an error. Right now, let's open our two_errorlog.txt file, and we can see test 1 has begun and finished, and all it says right now is that test 2 has begun. So let's step into LogErrors. And you can see what is happening. First of all, our errors variable that we initially set to 0 at the beginning of error handling start subroutine is being incremented by 1, because the only reason we would ever hit LogErrors subroutine is if an error was encountered. So this is the only place this variable is incremented. The next line we see here is it's checking to see if developer mode is set to false, which it is. Remember, we are in non-developer mode, or the user mode. Developer mode equals false right now. So what that means is that it is going to log in the immediate window, which are the debug print statements, and it is going to log the lines in our text file. If developer mode was set to true, then it would have gone down here to this else statement, and it would have only logged our results in the immediate window and not the text file, because the text file isn't even created when developer mode is enabled. But you can see the next if statement we hit is checking if error ID equals nothing. Now, error ID is another string variable, and it does equal nothing because we haven't changed its value. Error ID will come into play when I explain custom errors. So since we have not hit this, it does equal nothing. That means we want to enter this statement. And you can see these lines here are all the same as these lines here. The only difference is this has that additional line which tells the user to please contact your VBA developer. This is printed in the text file and not the immediate window, because if you're seeing the immediate window, more than likely you are the developer. So we will execute these lines, and we will see our immediate window now has these values. Error number 9, error reason, subscript out of range. The error number is specific to the error that's happening. It is not the total errors that we are recording up here. This equals 1. Error number is a ID that is referring to this error. Then we print a space in our immediate window, and we log the same lines in our text file. Now if we open up our text file, you can see it has given us the error number, the reason, and please contact your VBA developer. We hit the end if statement. We will not hit this else statement at all because this is when developer mode is set to true, and we hit end if. Right at the end, we set error number, that was 9, to 0, and error ID back to blank. These are very important, so we reset these and we step out of log errors. Now you can see we do have another subroutine being called here, but it is currently commented out. This is what we will explain next. So if we continue executing the code, you can see we will get another error message just telling us that errors exist and to check the file for further instruction. All right, so we know what error handling start does, just creating a blank text file for us, and then LogErrors is logging the details about the error, where it took place, what number it was, and a short description of what it was, and then a line to tell the user what to do. Please contact your VBA developer. Now we have the StopProgram sub, which is the subroutine that we saw commented out at the end of the LogErrors subroutine. So let's walk through again and we will uncomment this subroutine. All right, back into test 2. We will step over all the code until we hit LogErrors. We will step into this, and we already know what all of this does because we just reviewed it. So we will log all of these information. And right before we get to the end, we will uncomment this subroutine and step into it. All right, so the StopProgram subroutine is right here. You can see again, we have an if statement asking if we are in developer mode, and we are not. So developer mode equals false. Yes, it does equal false. So we will execute this code. Now, what will this do? Well, our text file that we've been writing to, we will close it, and we will set the two variables that are associated with it to nothing. Now, if developer mode was set to true, these 3 lines would be an error for us because they would have never been created and the variables would have never been set in the first place. So this line would cause an error because there would be nothing to close. That's why it needs to be inside this if statement. Once we have closed our file and reset our variables to nothing, we will call turn stuff on, we will call our closing message, and we will end the program immediately. So we will get the same error because it's calling the same closing message, and we will end, which will terminate the program completely. Now, this is your option right here. When you log your error, you can enable call stop program. If you do that, you will only ever log the first error that is encountered, whether that be a custom or a true VBA error. It will stop running all the code, and none of these subroutines will be run after this error was encountered. If you leave call stop program commented out, like I had before, even though test 2 encountered an error, test 3 through 6 will still be run and tested even though we hit an error. So it is your choice. Comment it out, test all your subs. Don't comment it out. The first time you hit an error, the whole program will stop. Both ways have application, but this error handler gives you the ability to choose for each project that you write. So now that we have reviewed the creation of our text document, the logging of the errors, and the potential to stop or allow the program to continue to run, we will look at the final subroutine of the error handler, which is error handling end. What is that doing exactly? So let's jump in. Again, we will start our master sub. We will step over, provide our save path, and step over test 1, step over test 2. We can't do that. So put a breakpoint on error handling end and just hit run. Give it your save path. We forgot to comment out StopProgram. So go to LogErrors, go to StopProgram or LogErrors and call StopProgram and turn it and comment it out for this example. And back to our master subroutine, hit run with a breakpoint on call error handling end, provide it your save path, and it should stop here. So let's go ahead and step into this to see what it's doing. Now again, you can see the first line is checking. Are we in developer mode? Yes or no? If we are, then we need to exit the sub. But we are not. It is set to false. So we will continue on. If errors equal 0, well, we know errors goes up when we call LogErrors, which happened in the test2 subroutine. So errors equal 1. So this will not happen. If we encountered no errors, like when test 1 was running alone and test 2 was commented out, errors did equal 0. Now, what would happen if that was the case? You have a couple options. This commented out line allows you to write a line in the text document that just says something like no errors found. This is an option, and I only recommend this for you to test if the document is being created and that you are able to write to it. If you are delivering this tool to a user, I do not recommend that you use this strategy, because if they run it, no errors take place, and an error log is still created, that might cause some concern on the user side. So instead, it just closes and deletes the error log that was created, because nothing was recorded except successful timed subroutines, which the user doesn't care about. So it just deletes the file completely. But since we do have errors, we don't want to delete it. What we want to do is just write a line and it says total errors equal errors, because errors increments every time we encounter one. It will be the total number of errors that were encountered for the entire run. And then it will just close the file. It will not delete the file, which is good because there are errors and they may need to refer to that document for further instruction. Once that's done, we are setting these variables to nothing, and then we are just turning stuff on and giving us our close message. All right, so now we have explained how the error handler works. We have explained the 4 major subroutines that are involved in the error handler. And now we're going to move on to different ways to use this. In step 7, we are going to show you how to create a custom error that will be treated just like the VBA errors, but it will give the user the opportunity to resolve the error on their own and continue to run their code. Back to the master subroutine, you see here call test3, and we have a little comment, custom errors. So go ahead and uncomment that block, and we will comment out test2 for now. We know there's errors, but these are just the VBA default error messages. And this will always give them a message that says contact your VBA developer if a VBA specific error occurs. The custom errors are going to be different. So we will leave test 1 because there are no problems, and we will only run test 1 and 3. So let's go ahead and step into this sub. We will execute these, provide our save path, and step over test 1, and we are going to step into test 3. So the top part of test 3 is the same exact as test 1 and 2. On error, go to error handler, subname equals the subname, in this case, test 3. Our developer messages, test 3 has begun, and our timer has begun. Now this is our specific code that we've written. And here we are giving the user an input box, and we're just putting it into a variable that says answer. So answer equals input box, please enter your name. Let's execute this line. Now, when we give the user an input box, typically we do not want this to be empty. Just like at the beginning of the master sub, when we call the save path input box, we validate to make sure it's not empty, because if these input boxes are left empty, it could disrupt our code further down the line. So let's leave this empty and see what happens. You can see we have a validation if statement here. If answer equals nothing is empty, then do something. And in this case, we are going to change the string variable error ID that we saw earlier to user did not enter name. And then we will go to error handler. So after you put on error go to error handler at the top, you can write go to error handler wherever you want. So you can create this custom ID. This can be as detailed as possible for the user to do this, to be able to correct the problem on their own. So this could say user did not enter name, please do not leave the input box blank. It could say something like that. But we just put user did not enter the name and we hit go to error log. So we will go to the error log. And let's step into this again. Now this is going to act slightly different because this is not a VBA specific error. This is a custom error that we've created. So again, errors will be incremented because we're counting VBA errors and our custom errors all as errors. We're checking developer mode is false, which it is. And then we are checking error ID equals nothing, which it does not. It does equal something, which means it will not execute this like we did before. It will jump down to this else statement and it will debug, print, and write in our text file, but it will write different lines. Since there is no error number and error reason, which are VBA objects, we have to print our own lines. So we say right here, error, user did not enter name. And you can see we just put the word error manually here, and then we give it the error ID string value that we created right before we called the error handler. So you can put, like I said, whatever you want here. And these same two lines will be logged in our text file. And we will hit end if and reset our variables. So once we jump back to end sub, let's go to our error log and see what happened. And since this is OneNote, again, we have to refresh and we'll see 7_error log was created. And you can see here, test 1 ran successfully and then test 3 has begun. And then we get our error message, error, user did not enter name. That is why in that final error message that pops up, it says, please see this document for further instruction, because it could say contact your VBA developer, which we could then just put in the message, or it could give them a solution that you've crafted for a custom error like this one. Now you can see this is a good point to show the difference between the developer mode and being false or true. Right now, developer mode is set to false, and you can see our file path that we gave the program is filling up with right now 7 error logs. Now, if I'm the developer and I'm testing over and over and over and I'm running into errors and I know I'm going to hit errors, this could create 100 files depending on how many times you test your program. So enabling the developer mode to true stops these from being created at all, and it only prints the error messages in the immediate window, which means you don't need to leave VBA, come check a text document for the errors, and then return to VBA to fix them. Everything is in VBA so that you can fix it, and no text documents are being created at all, so you never have to delete them. And when we want them created, we just set it to false, and when we don't, we set it to true. It's very handy. So once test 3 custom error was logged, we can execute the rest of our code, and you'll see we'll get this same message. Since errors was incremented, we will get the error message at the end. So one last look here at the custom errors. This can be, again, whatever you want it to be. If you want the user to do a certain thing and they fail to do it, you create a validation block of code to check if they did it. If they did, move on. If they didn't, then change the error ID to something, describe how the user can avoid getting this error again, and then go to the error handler. And they'll be logged just like every other error in VBA. So now that we've explained how to create your own custom error messages that interact with our error handler and will provide the user instructions on how to avoid that error, we run into the possibility of dependent errors. And what I mean by that, if we have a custom error message and we do not hit stop program, meaning we allow all of our subroutines to run, which we're going to show here, where we know test 3 is going to error from our custom error. Test 4 is reliant on the answer variable. And therefore, if the user leaves the input box blank, which will cause the custom error, but our code continues to run because we did not execute stop program, then test 4 will error as well due to the error in test 3. So let's walk through it to make it a little bit easier. We will step over, provide our save path, step over 1, step over 3. We will leave this blank because we want it to error. And you can see right here, test 3 has begun. Error, user did not enter the name, so we know we logged our error. Now we will step into test 4. Again, the top and bottom are the same for every subroutine. On error, go to error handler, subname equals test 4. Step over this. It's telling us that test 4 has begun, and we are starting our timer. Now we're starting our code. You see we have another answer variable here, answer2 equals message box. You've entered your name as, and it gives us the answer variable that was just asked for in test 3. In this case, it is blank. Is this correct? So this is another verification. This is just a simple example. And we're putting VB yes, no. So it's a yes or no option. And we're just titling it verify name. So let's execute this. And you see we get a verify name pop-up box. It says you've entered your name as, nothing is there. Is this correct? Well, since there's no name there, no, it's not correct. And then we have a validation if statement. If answer2 equals VB no, which it does because we clicked no, then do something. Error ID, another custom error, equals user clicked no when asked if the name they entered was correct. Okay, go to error handler and we will call LogErrors. We will increment and print our statements. Error, user clicked no when asked if the name was entered was incorrect or was correct. Okay, we'll reset our variables and we will execute the rest of our code. So the reason I'm bringing this up, let's open our file, and we can see test 1 has begun and finished. So try to look at this example as if the user is contacting you and said, this error log was spooled out and I don't know how to fix these errors. And you notice how many errors are there? Okay, there's 2 errors. But is that really true? Think about the dependency. test 4 is dependent on test 3. So if we resolve the errors top down, meaning test 1 was finished, we don't need to resolve anything. Test 3 has begun, error, user did not enter a name. Okay, let's resolve this. When that error is resolved, this error will be resolved. That means this is a dependent error. So you need to use the StopProgram subroutine strategically based on what you're trying to do in your program. Because if one subroutine can error and then it can cause 4, 5, 6 more subroutines below it to error because they're all dependent on a variable or a value coming from that first errored subroutine, then you probably want to use the StopProgram subroutine. But if they all are independent and do not rely on each other, you probably don't need to worry about these dependent errored issues. I just wanted to make sure people understood what could happen if you do not use the StopProgram subroutine. All right, now that we've covered custom errors and dependent errors, we can comment both of these out and we can get to nested subs. So if you don't know what a nested sub is, these are nested subs, meaning we call a subroutine to run and then this subroutine calls other subroutines. So every subroutine in this subroutine is nested. This is the master and this is nested inside the master. And this is nested inside the master. Now, so far, if we go to test 1 for an example, we've called a nested subroutine, which is fine, which is how it's designed to work. We execute code and we leave this subroutine. This could be considered, well, these are nested subroutines. But what if you want to do one that's not default? These are default and these are the things that cause a problem for your custom nested subroutines, which would go here in the middle. So let's go back to the master and comment test 1 out because we don't care about it, and uncomment test 5. So there are 2 ways to handle subroutines or nested subroutines. In test 5, we'll show a more detailed, or let's say granular or optimized way to handle them. And then 6, we'll show you another option that you can do if you just want to run the subroutines and you're not worried about so many details. So let's start by running 5. Let's step into the master, step over these, provide our save path, and step into test 5. Okay, you can see, I'm going to move our immediate window here. You can see there is a little bit more going on in this example. And the first couple of lines are a little bit different. So on error, go to error handler. That's the same. But the second line, sub name equals, instead of just test 5, it's test 5_1. Now the reason is because we are going to call our developer message to start right here, which is going to say test 5_1 has begun, because that's the subname we just gave it, and it will start our timer. We will execute any code that we put here, if you put any code, and then we will stop our timer, because this is just the code that exists so far. And we will say test 5, the part 1 of the test 5 subroutine has run successfully, and now we're going to call a nested subroutine, because if we just called the nested subroutine in this portion of the code and we did not stop our timer and log it, then the timer would have restarted when it entered this subroutine, and we never would have got a full time for this sub. So if you're really concerned about getting the accurate times for every subroutine, this is the way to do it. So now we're calling this subroutine. We'll step into this and you'll see this looks like all the other ones that we've written so far. On error, go to error handler, subname, nested sub, that's the name of the sub. We start our message where it says nested sub has begun. We start our timer we end our timer, and we log the amount of time it took to run. These are all messed up, so I'm just going to clear them. We don't hit any errors, so we exit the sub. And now when we come back, since we're nested inside test 5, we're coming back to test 5. We have to tell it to go to error handle again if we hit an error. We are renaming the sub again to test 5 part 2, and we are calling another developer message to tell us that part 2 is starting, and starting another timer to time the second part, and stopping our timer and logging how long it took the second part to run. Now what we could do with these parts, which I have not done here, is you could get a formula that takes the value of the first part and stores the time in a variable and then adds it to the second time, and then it logs the total time for that run. But I have not done that here. And then we will exit the sub and continue to run our code. Run successful. So that is the first way you can handle nested subroutines while using this error handler. This might be a little chaotic with these developer messages and the timer start and stop all over the place. But if you wanted to keep it a little bit simpler, then we can see an example here in test 6. So let's comment out test 5, uncomment test 6, and we'll jump into this one. So let's step into our master, give it our save path, and step into test 6. You can see test 6 is much simpler than test 5. Now this is because we are not stopping our timer or logging that part 1 of test 6 ended or started. We are simply treating this the same as every other subroutine, meaning on error go to error log, test 6 is the subname. There is no part 1, no part 2, even though we're calling nested subroutines. We are telling our developer that test 6 has begun, starting our timer, and then any code you're executing would go here, and then your nested subroutine, you can continue writing code after you've called your subroutines. And there is no stopping of the timer to log that part 1 is complete. We're just going to call the nested subroutine directly. If you do this, you will not get as much detail, which isn't that big of a deal, but you also need to structure the subroutine, the nested subroutine, a little bit different. I stepped over it on accident, so we will just execute and re-enter so that we can step into it right here. Okay, we need to break it here. Provide the save path and step into this, and we want to step into this subroutine. Okay, so we'll close this. You can see we have a message just like we always get. Test 6 has begun. Now let's step into this subroutine. This is a little bit different. All we have on this nested subroutine is on error, go to error handler. That's it. And then we have the code, and we have exit sub and our error handler. There is no developer message start, there is no timer, there is no developer message end, and there is no ending timer. Those cannot run and be accurate if you do not stop the timer before entering your nested subroutine. But if you don't care about that granular detail, then you can just do it this way. Make your nested subroutines a little bit simpler, execute the code. In this case, we just have a debug. So you can see the code is being executed inside the nested sub 2, not test 6. We'll exit the sub, we will return to sub 6, and we will give our message there, which we say test 6 ran successfully and it took 66 seconds to run. But that's not entirely true, because test 6, it took this long to run, but while it ran, it also ran other subroutines. That's what I mean by you're not going to get as much detail doing it this way, because the time that it's telling you is a total time for this sub to run and any nested subs to run. Doing it the way you do in test 5, you will get specific times for your nested subs and test 5, as we can see in our previous error log, which we can see here. I meant to show that before. So let's clear this. Take this breakpoint off. Comment out both of these, 5 and 6. Leave them both uncommented and just run our, also uncomment 2. So our error log will not be deleted. So let's execute, paste our path. We got an error. Now let's open our log. Refresh. All right, so you can see here test 2 failed, and it gives us our message, please contact your VBA developer. We expect that. But now we can see the difference between detailed subroutines and a little bit not detailed. So part 1 of test 5 ran, and it took this long to run, and then we ran this nested subroutine, and that took this long to run, and then the part 2 of test 5 subroutine took this long to run. Now, this one just says test 6 began and finished, but we know a subroutine took place in between this began and finished. It just doesn't tell us how long it took to run specifically, like this one does here. So this will be a preference thing, but you have the option either way which one you prefer. That's why I gave you both in this example. All right, so we have completed the overview of this error handler. And I know this was a very in-depth video. I hope this helps you guys. If you download and use this in your projects, please let me know how it works for you. If you run into any issues that I didn't explain here, feel free to reach out anytime. Join my Discord server and you can reach out to me directly.